First, for the Profinet is short for the process field net. It's a protocol to exchange the data between the controller and the devices. Controller will be the PLC, DCS, and the device could be the I/O block, drives, process, or processing instruments or other controllers. Normally, when we use the Siemens PLC, we need to use the Profibus or the Profinet. This photo is the network in last year all over the world. For the blue color, the field bus, like the Modbus, Profibus, Open Device Net, it's developed based on the RS485. The field bus is about 30%. And this color is the developed based on the industry Ethernet, about 64%. The Profinet is about 17%. Ethernet is also 17%. Another is the wireless, about 6%. This color, we can see this is the Profibus cable. Before, when we use the Siemens PLC for the Profibus communication, we must buy the special cable for Profibus communication. This price is very high. For the Profinet, now we can use the standard network cable. Can use the C85, C85E, or the C86. This is the bus circle time. For the Profibus, the maximum is about 12 megabits per second. The Profinet is developed based on the Profibus and the network standard Ethernet. So the maximum now is about 100 megabits per second. Now also have the gigabit. And this is the Profinet ISO OSI. We know that the OSI layer, the first and second layer is the physical Ethernet. The Profinet is in the seventh layer, it's application layer. The Profinet also is the real time. The standard TCP IP is not the real time. In the factory, normally for the factory automation, like the inverter remote I/O, we need the real time. The response time is about 1 to 10 milliseconds. The standard Ethernet with for the websites like that, it's about 100 milliseconds. For the motion control and the highest performance, the response time must less than 1 millisecond, like the Roboter. So normally for Siemens S7-1200, the Profinet only supports the RT. It's a real time about 10 milliseconds. This page is the topology. For the first, this is the linear topology. We connect the computer to the Siemens PLC, and the PLC connect to the inverter. Also can use another topology. All the computer, PLC, and drives connect to the Ethernet switch. And this is the Siemens PLC. Today, we borrowed the PLC. It's the Siemens S7-1200. It's the CPU 1215C. It's AC power input and relay output. The program date is 125 KB. This PLC it includes two RJ45 Ethernet port. It supports the Profinet I/O controller, Profinet I/O device. Not support this IRT. The IRT the response time is 1 millisecond. This CPU only supports the normally Profinet I/O. So the response time is 10 milliseconds. The transmission rate is 100 megabit per second. The driver is the GD350A. GD350 is the IMVT, a multi-functional high-performance inverter. It supports the speed control, torque control, and the position control. Also have the two modes. One is light duty, P mode, and heavy duty, G mode. It supports the induction motor and the permanent magnet motor. This power rating from 18.5 to 110 kilowatts already built in the DC reactor. It can reduce the power input factor. Bigger than 7.5 kilowatts, it has 3 slots for the optional cards, for I/O cards, PLC cards, PG cards, Profibus, Profinet can open, Ethernet IP, EtherCAT, and others. There is a STO terminals on the control board. All the inverter comes standard with the LCD keypad. Less than 37 kilowatts, it built in the DBU. 45 to 55 kilowatts, it's optional built in at the dash B behind the model. The right photo is the Profinet card for GD350A. The model is EC-TX509. It includes 2 RG45 ports. This is the inverter setting. Before we use the Profinet, we need to set as this following. First is the P0.01 equals 2. This is the communication control. P0.2 equals 3. It's the Profinet control for start-stop. 0.6, 13. This is the frequency channel. We select the Profinet. P16 group is for the Profinet setting. From 2 to 5, it's the IP address. The default is 1. We change this 192.168.0.2. We must make sure our computer IP address and the PLC address, the first 3 IP must be the same, and the last one must be different. P16.31 equals 0.0. This is the Profinet communication timeout time. Some software version, the default value is 1 second. So if we not set 0, after we insert the cards and power on inverter, the inverter will display the Profinet communication error. So we can set 0 temporary. After all the network are working well, then we can set this. P16.32 equals 1. This is the PZD2 receive. When we want the PLC to set frequency, we write the date to the PZD2 receive for set frequency. P16.43 equals 1 is the PZD2. 43 to 46 is the PZD sent. It means this data will transfer from inverter to the PLC. I cite, you can also set by yourself. This is just my setting. I transfer the running frequency, setting frequency, DC bus voltage, and the motor RPM. After we set all, after we change this IP address, we must power off and power on again. For the Siemens PLC software, now we use the TIA Portal. This software is for create the project for the Siemens 1200 PLC or other series like the 300, 400, or 1500. After we open the software, we must firstly install the Profinet GST field. If we not install this field, we cannot add the other branch inverter to this project. Only can join the Siemens drive. Firstly, create a new project and then add the CPU. This CPU model must be the same with your real PLC. And then add the IMVG GD350A station for the memory allocation. For the this memory is for set the Profinet communicate address, and then the IP address setting, connect the work, save the project, compile, and download to PLC. And this photo is address like this. We use the M0.0. It's for start, 0.1 for stop. This is the internal memory. Memory words 40 for setting frequency. It's a control word running frequency from memory word 50 to 90. 60 to 90, this is the value transfer from the inverter to PLC. Like this part, this is the PKW and the PZD field. This field, we can think it's like the black box. PLC transfer to this, and then the inverter transfer this to the PLC. Control word, this control word, states word, is for PLC write control word and the state word back to PLC. PZD234 is we can transfer the data for the set frequency and feedback the frequency motor RPM. PKW1 to PKW4, this four words is used for read or write the parameters value. Like this. This part I set the Profinet input address from 100. Q is output address 200 from 200. This is the control word details. Like this, it's similar with the Modbus. First, from bit 0 to bit 7, set 1 is forward running, set 5 is stop. This is state word. State words, if the inverter is in forward running, this value is 1. This is the internal memory from PLC to the inverter. This the blue color. This color is PLC. After we set the PLC QW output to 200, the 200 equals the PKW1, inverter PKW1. Control word QW208. After we send the data to QW208, it will transfer to the control word. So we set this P16.32 equals 1 is the PZD2. PZD2, we use the set for setting frequency. We just change the date QW to 10. And this part is the date transfer from inverter to PLC. The input word is from 100, so the input word 100 is the PKW1. This state word wait a moment, there is very noise. Okay, this inverter state word will transfer to the IW108 automatically. So we set this P16.43 PZD2, it's the running frequency, equals 2 is the setting frequency, 3 is the DC bus voltage, 46 equals 8 is the PZD5. I set 8 is the motor running speed RPM. If we want to read or write the parameters value directly, we can use the PKW1 to PKW4. But this is very important. If we want to change the PKW, we must write the control word bit 8, enable writing the PKW1 to PKW4. PKW1, the function is we write PKW1 equals 1. It means PLC will read the parameter value. Write the PKW1 4 equals 4. It's used for write the parameters value. Like this, PKW. PKW1 is for read or write. PKW2 is for change the parameter address. The PKW3 is the value array number. PKW4 is the parameter values we want to read or write. We just change read write, just read the data from the PKW4. So this the logic process is the firstly we write the control word bit 8 equals 1, 0100 hex value. Then we write the PKW1. If we want to write the parameters value, we write equals 4. If we equals 1, it's for read the parameter value. PKW2 is the parameter address. PKW4, we write the value Q or read the value 1. If we read, just read from the PKW4. If we want to write, just write the values which we want. So later, I will show you the process option by the TIE portal. This is the Siemens. This version I used is the V14. Firstly, click this, create the new project. Input the project name. We use the Profinet test. Create. The Siemens Portal software is very large, so it needs the high performance computer. Click this, open the project view. After we open this project view, firstly we must install in this option, install the GSD file. Source path. This is for select the GSD file position. I saved in this file, so click this and select install. Okay, close. After we install the GSD file, the hardware list will include the INVT drives. Firstly, we add the new device. Today my PLC is this S7-1200. This one. My PLC is the AC input, so this 1215C AC/DC relay. You can find this model on the right side of the PLC. This is the same with my PLC. So select this, click the OK. Portal software is sometimes it's slow. So if you want to use the fast portal, suggest to use the SSD hard disk. Already opened. This is my PLC. We can insert other hardware if we have the external I/O module all this for the communication. And in this, click this network view. Select the INVT product here in this part. Other field device, Profinet IO, INVT. INVT Profinet adapter. Click and move to here. If we connect two pieces, we can also add another one. Now only have one, so only need one is enough. This is my inverter. Firstly, here, the blue color, not assigned. We click here and select this PLC Profinet interface, and already connect to the PLC. Then we switch to the device view. This is my adapter. Here, this part is for set the input and output address. In this here, the module input output, we can use this 32 bytes input and output. Move to here. This is the input and the output address. We can set by yourself. I set the 100 for input and 200 for the output. And then we modify the IP address. Double click this. There is the Ethernet address. Already default is 2. And then we check the Siemens PLC address. Here, select the PLC CPU. Yes. The address is same, but the last one is the 1. And then we must check our computer IP address. Here, local. IP4. We must make sure this. The first IP must be the same. Only the last one must be different. Okay. After this setting, we compare the device configuration. Today I connect the PLC like this. Computer connect to the PLC, and the PLC connect to the inverter. Already compare and download. Click this, download to the PLC. Here, this part for select the network card. In my computer, there are two pieces card. One is the wireless, and another is the local card. We select this.
Wireless.
And then select the start search. The software will find the network automatically. Already found the PLC, found the drive. And wait a moment. Already found this PLC. It will detect the model automatically. 1215 AC/DC relay. This is a flash LED. If we select this flash LED, the green LED on the PLC will flash. And select this load. Stop. This will download the network device configuration to the PLC. after finish, we can click this, go online. This color must be green. This one must be green. It means the software already connect to the PLC and already detected the inverter. If this color is not green, like the yellow, orange, or red, it means the network have the problem. You must check the network configuration. Maybe the IP address, maybe the you didn't power off and power on after you set the IP address. So now we can. I will show you how to program the communication. Firstly, we can add the memories like the field. Oh, wait a moment. PLC check. Use this memory. So set here. Here is address. Firstly, start stop. We use the M0.0 for start, M0.1 for stop, and the setting frequency we use this. This MW40 is for GD2 for setting frequency. It's right to QW, so we use MW40. MW40. It's a memory word 40 to the QW210. QW210. QW50 for control word, for set the control word. So it's QW50. QW control word. And for the read the running hertz from the PZD 2345. Input to this. Input word 110. 110 is used for the transfer the running frequency to the PLC. It's the MW60, IW1 to MW70. For start, stop, MW40 is for the set frequency. It's the set frequency. QW50 is for it's a control word. It's for start or stop. The QW208 is a control word. Input word 110 is for the running hertz. It's memory running hertz. IW112 is for the setting hertz. DC bus voltage. DC bus voltage. It's for motor for transfer the motor RPM. Then open this, the main program. Normal open this for start M0.0 start. M0.1 stop, and use this function block move. Firstly, we change the set frequency. We use the memory watts 40 to the QW208. Oh, sorry, it's the QW10. MW40 is used for setting frequency, so we move this date to this date. Then for start, move the MW50 MW50 to the control word. Control word is QW. MW50. Hey, there I forgot. Sorry, I forgot this. MW this here. M50. MW50. Start stop, and then this is for set frequency. This is for set frequency. This row is for start stop, and then when we transfer the date from inverter to the PLC, still use the move. IW110, the running hertz from the IW to this MW70. We can copy the function block IW112. Oh, sorry, this running hertz MW6. IW114, MW82. Motor RPM, input volt 116, MW90, motor RPM. This for start, and then we add the stop, M0.1. For stop, we just write the control word, move the MW50 to the QW 0.8 control watt. After we also transfer the inverter running states back to the PLC. Copy this: running hertz, setting hertz, DC bus voltage, motor RPM. Copy and paste here. And then we can build the watch table for monitor the memory value. The control watt is very important, so we monitor the control watt, control the QW208 and the QW20210 is a set frequency. And here IW108, this is the state watt. Also IW state watt. IW110 is the running hertz, setting hertz, DC bus voltage, the motor RPM. Then monitor the start stop. The start is M0.0, M0.1 is the start stop. The set frequency is the MW40. MW50 start stop 60, MW70, MW80, 90 motor RPM. For the running hertz, we can select this DC value. It's more easy to understand. DC. We know that because this value is the PZD received and the PZD sent like this. The running frequency, set frequency, and the bus voltage, the unit difference, it's the equals 100 hertz. So this must be multiple 0.01 hertz. DC bus voltage is 0.1 volt RPM. Set frequency we already modified the program and the PLC tag and the watch table, then compare again. compare again and download to the PLC. This is the green color. Now it's online. We open this watch table. Click here, monitor all the memory. This is the DC bus voltage. Because after it's running, the Profinet already communicates, so this will display the DC bus voltage. If we want to start, firstly, start set 1, and the set frequency we set 40 Hertz, and this equals 1. It's like the control word, so we equals 1. 1 is the forward running. This for start. Click here. Here is the modified value. Now the inverter is running. We can see that this is the running frequency increased, and the setting frequency is the 40 Hertz. Then the DC bus voltage 312 volts. In my office, I test the inverter is the 220 volts, the motor RPM. We change the frequency to 25 Hertz and click here. Now the frequency reduced from 40 Hertz to 25 Hertz. If we want to stop, we firstly the setting frequency set 0, and then this is the for control word. We set 5. 5 is the stop. This like the button we for stop. Modify this. We can see the frequency reduced and motor RPM reduced. Okay. This is for the Profinet for start and stop. For this, if you want to read and write the parameters, I will not program. You can test by yourself. Firstly, write the control word equals bit 8 equals 1. Control word bit 8 equals 1, and then read. If we want to read, we set the PKW1 equals 1. It read parameters. If you want to write, we set this PKW1 equals 4. It will write the parameters. The PKW2 is the parameter address. Similar with the model bus, it's the 16 value. PKW4 is the value. If we read the value, we just read from the PKW4. If we want to write, we also change the value, write the value to the PKW4. It will transfer to the inverter.